Like, comment, subscribe, and let's do this.
The universe looks like a vast empty ocean sprinkled with rare islands of galaxies. But this is an illusion. Just a small fraction of all atoms are found in galaxies, while the rest is thought to be drifting in between, in the intergalactic medium. Like the roots of some massive tree, gas spreads out from each galaxy, gravity funneling fresh mass into this dense cosmic forest. Here in the intergalactic medium are the raw materials of creation: hydrogen and helium, woven into sheets and filaments that flow into galaxies where they eventually create stars. But if we look closely, we see who's...
Wait, before we go any further, I want to know, what is space expanding into? Is it writing itself as it's going? Or it's expanding into a pre-existing space? If somebody knows that, please put that in the comments. I would really like to know, because it wouldn't be making sense for it to be expanding into a pre-existing space. But then again, how do you create space as you're going? So that's mind-blowing to me. If somebody knows, please put that in the comments. Illuminate your boy.
Actually in charge, quasars, the single most powerful objects in existence. As small as a grain of sand compared to the Amazon River, they reside in the centers of some galaxies, shining with the power of 1 trillion stars, blasting out huge jets of matter, completely reshaping the cosmos around them.
Damn.
They're so powerful that they can kill a galaxy. What are they, and how do they mold the structure of the universe at their whim?
Let's go. Man, I enjoy these videos, so I'm going to keep reacting to them.
Everywhere you look, weird things in the sky. In the 1950s, astronomers noticed mysterious loud radio waves coming from spots all over the sky. They were named quasi-stellar radio sources, or quasars, because they were dots like stars but were seen in radio waves rather than visible light. Everything about them was strange. Some flickered, others emitted high-energy X-rays in addition to radio waves, but all seemed to be tiny. They all moved extremely fast, as much as over 30% the speed of light.
Whoa.
The only explanation was that they must have been so distant that their apparent speed was actually the expansion of the universe moving them away from us. But these enormous distances meant that quasars couldn't just be stars, but the active cores of galaxies billions of light years away. And it gets crazier. To appear so bright and loud, given these vast distances, they are thousands of times brighter than the entire Milky Way. Monsters exploding and screaming into the void with a violence not thought possible before. As we mapped the sky, we discovered over 1 million quasars, and they all seem to be very far away. Looking into space far away means very long ago, because light takes so long to reach us. Quasars were common in the early universe, having peaked in number 10 billion years ago when...
So basically, we could be looking at quasars that are non-existent, like they don't exist anymore. The ones that we are looking at, not to say that they don't exist anymore as a whole, but it's possible that the ones we are observing died long ago, and the light to tell us that they don't exist anymore may have not reached us at this very moment. I think that's what he's saying.
When galaxies and the universe itself were still very
Quasar
young.
prime time.
Let's go back in time just 3 billion years after the Big Bang and see what was going on back then. The incredible power of quasars. How could an early baby galaxy be so incredibly bright and violent? All that light and radiation couldn't be stars, as there weren't nearly enough of them. And since galaxies tend to grow with time by merging, the starlight from small galaxies shouldn't be far brighter than any galaxy today. There's only one way to generate the vast amounts of energy a quasar shines with: feeding supermassive black holes. We still don't know how exactly they formed, but it seems that every galaxy has one in their center. But how can the brightest things in the universe be black holes which trap anything and everything that crosses their event horizon? Well, the light of a quasar is not coming from inside these black holes. Rather, it comes from the space around them, a massive orbiting disk of gas called an accretion disk. Quasars use the same fuel as stars to shine: matter. It's just that black holes are the most efficient engines for converting matter into energy in the universe. The energy released by matter falling into a black hole can be 60 times greater than that released by nuclear fusion in the core of a star.
Damn!
Because the energy released by a black hole comes from gravity, not from nuclear reactions. Matter falling into a black hole speeds up to almost the speed of light before it crosses the event horizon, buzzing with an incredible amount of kinetic energy. Of course, once inside the black hole, it takes that energy with it. You only get to witness this energy if you drop your matter in the right way, fall straight down, and the outside universe gets nothing. But when you have a lot of matter, it spirals in incredibly fast towards the event horizon, forming a disk. Collisions between particles and friction heated up to hundreds of thousands of degrees.
Yep.
In a space not much bigger than our Sun,
I was just about to ask, like, is that why they light up? Is it because they spin at such a high velocity that they burn up and then light up into this thing? It's basically like a liquid magma or something of that sort. I might be wrong, so put that in the comments.
solar
But that's
system,
what I'm getting
the
from
core
it.
of a galaxy can release many times more energy than all its stars combined. This is what a quasar is: a supermassive black hole having a feast. And these black holes eat a lot. Typical quasars consume 1 to 100 Earth masses of gas per minute. 10 billion years ago, the universe was about a third of its current size, so the intergalactic medium was much less spread out, meaning the filaments of gas around quasars could feed them a banquet,
Yeah.
making them vomit insane amounts of light and radiation. The
Man.
brightest quasars power jets, tangling the magnetic field of the matter around them into a narrow cone. Like a particle accelerator, they launch enormous beams of matter out, ploughing through the circumgalactic medium, forming plumes of matter that grow to hundreds of thousands of light
This is
years
so
in size.
insane, bro.
It's almost unfathomable in scale. A tiny spot in a galaxy carving out patches of the universe hundreds of thousands of light years long. But quasars can't eat for long, maybe a few million years, because their feast ultimately kills their galaxy. How quasars kill galaxies. Okay, maybe killing is a bit of an exaggeration.
So because I'm going to guess, I'm trying to guess, as these quasars like consume these planets, that it's a two-way thing, I think. They consume the planets around them, plus they spew these jets which destroy and push away planets from around them. So I guess that's the two ways it does it. But let's hear what he has to say. I might be wrong.
A galaxy is still there after its quasar turns off, but it will never be the same again. Quasars, being among the hottest and brightest things in the universe, break their galaxies by heating them up too much and stopping star formation. Stars are gas that collapsed in on itself and then got really hot. But in a cloud of gas that's already hot, atoms are moving quickly. When they collide, they hit hard, exerting pressure that resists gravity's squeeze. So hot gas cannot form stars. Instead, the best gas for forming stars is already cold and won't put up a fight when it's time to collapse into a star. On top of that, quasars push gas out of their galaxies. Not only does this starve the quasar, but its galaxy loses the raw materials for new stars. As sad as this sounds, it might be a good thing for life. The alternative can be far more dangerous: too many stars. New stars forming is usually followed by massive stars exploding in supernovae, so planets would be burned sterile. But of course, it's more complicated. Like the intricacies of our own planet's biosphere, every piece of the galaxy is dependent on and influencing every other part of the galactic
Yeah,
environment.
everything
While
works
hot things
together.
like quasars and supernovae tend to push gas out of the galaxy, shockwaves and quasar jets can also compress gas, making new stars at least for a short time. But in general, we can
But isn't that insane that everything in the universe works together just as the same as how things are on Earth? Like everything is symbiotic. I think that's the word for it. If there's another word I'm looking for, please put that in the comments. But I think symbiosis is the word to use.
say that without things becoming a bit more chill,
Everything plays
we
a
would
part
not exist today.
together.
Which brings us to our final question. Did the Milky Way have a quasar in the past? It's unclear if every galaxy went through a quasar phase, but understanding distant quasars may provide clues to the history of the Milky Way. Galaxies don't do a good job of preserving their history. Like sand on a beach, the endless churning mixes away the clues to their past. It's possible the Milky Way was once a quasar, which may have allowed our supermassive black hole Sagittarius A star to have grown to 4 million times the mass of the Sun. And as dormant as it is
That's
now,
huge.
Sagittarius A star could turn into a quasar in the future. In a few billion years, the Milky Way will merge with Andromeda. We've seen over 100 double quasars in galaxies smashing together, where fresh gas is provided for the central black holes. But it won't last for long. When galaxies merge, so do their supermassive black holes, sinking into the center of their new galaxy, kicking up dust and stars in every direction. We don't know whether this will happen, but it would truly be an incredible sight. Maybe some beings in the far future are going to witness it and be in awe of what they see. But you don't have to wait that long. There are already plenty of fascinating things to explore right here on this planet, right now, if you have the knowledge to understand them. To help you with that, we've created a series of lessons to take your scientific knowledge.
Is that an ad? I think that's the end, yeah. Yeah, so that's the end of the video. But every time I watch videos on this channel, I'm always mind blown. Always mind blown. So this was very educational too. I've learned something new. And every video is always something new. But I've realized like the videos I've been reacting to from this channel lately have all been about black holes. But if you want me to react to something different, please put the links to the specific video you want me to react to from this channel in the comments. Or even if it's about black holes, it's still okay if it's something different from what I've reacted to already. And on that note, thank you for watching, and I'll catch you on the next one.